You know shit gets serious when dial gauge comes out.
What's up, everyone? My name is Biku, and I was very happy when I first got the CNC. This one, that one right there. Yes, that is a CNC. I was very happy when I got it, but it is rather old, and by rather old I mean probably upwards of 15 years old. So while it was probably really, really, really good when it was first built, since it is a mini milling machine, literally just called the mini milling / drilling machine. It was converted into a CNC by a company local here, and that's great. It works perfectly, not perfectly, but it works very well. Only thing is, I have been having a lot of problems with overall accuracy. I don't know if it's here, but I tried just doing a circle, which is supposed to be a certain diameter, and it ended up being not that diameter, even after meticulously measuring the pitch and working out the steps per millimeter for this. And as it turns out, and I'll show you this now, try not to crash into the dial gauge since it doesn't really like that very much. Okay, I have zeroed Z, and I am now going to move the head, so it should move instantly. I'm pressing. That's the down. It's not moving very fast. There you go. You can see it moving now. But it showed that it's moved 0. That's in millimeters, not inches. But it showed it's moved 0.17 millimeters, and it has only moved about 0.5 millimeters. That's bad, obviously. So, problem. But Mach3 has a backlash feature, which is great. That's perfect. I have set up the backlash for the X and Y, and they now move perfectly with the backlash settings that I have. And you can see 0.25 and 0.22 millimeters respectively for the backlash. Or could you even see that? Yes. That's a lot of backlash. And even after tightening the gibs, which tightening these were a pain in the ass because there's this aluminium bracket that covers up two of the gibs. So that was fun. But I think, and these are ball screws, but I think over the years they have just sort of lost their I don't know what the word is. They've worn down or whatever, or they need to be re-greased or something. They've lost their accuracy. So I could replace the ball screws, which I probably will at some point, but that is probably going to be a monstrous task. And the ball screws themselves aren't that cheap. Replacing all of the ball screws will probably cost around $2,000. In South African currency, it's about 2,000 rands, which roughly equates to around $10, somewhere around there, more like $170, but it's not cheap. That and just a couple other things. The spindle retaining, or not spindle retaining nut, but the collet holder retaining nut, that's completely stripped. Let me see if I can do this with one hand. That's going to be interesting. Really, really interesting. How the fuck am I going to do this with one hand? Okay, so that has to go that way. That has to go there. Oh god. Oh god, this is going to be interesting. Is that right? Yeah, that... Fuck. Okay. So... that should go there. That should go there, and that should loosen. There we go. That loosened it enough, I think. So, there we go. I don't know if I even got that on camera. I was actually trying to get it out, so sorry. But you can see those threads. Come on, focus. Those threads are fucked. But I think what happened at some point is someone cross-threaded them going in. Someone cross-threaded it going in. Like, going in. Or someone used this, put it in, threaded it, and tried to bang out the collet holder. But I think it's okay because it's really rough, like most of the way. But then here, they thread in really nicely. So that sort of tells me that when it actually threads all the way, it's actually contacting all the threads. And there goes my thing. But what that tells me is when it's actually threaded all the way, it's actually contacting only good threads. Which is good, but with how much of a mission it was trying to get that out, I don't think it's going to come out even if that's completely loose. But anyway, that's another thing that needs to be done. But let me show you what I mean here. So right now I've got no backlash compensation on. What I am doing is I'm going up and then I'm going down until I get past the backlash. There you can see I'm past the backlash going down. And I'm just going to get onto 0. And then with no backlash compensation added, I am going to go G1, Z, -8, F100 because it's a dial gauge, I don't want to completely fuck it up. Oh fuck. G1, Z, -8, F100. So it's going to go down 8 millimeters at 100 millimeters a minute, which really isn't that fast. So it should go around 8 revolutions exactly. And and as far as I know, the ball screws on X and Y are exactly the same as the ball screws on Z, which admittedly they may not be, but I can't easily measure those. So this should go around 8 times. And you can see there, each little tick on those dials is 0.01 millimeters. So that is off by 0.05 millimeters. So that's 0.05 millimeters too little because it's backwards, so clockwise is... Anyway, 0.05 is too little. So, motor tuning, you can see I've got the X, that's X, if it'll focus, there we go, the X and Y, oh sorry, that's X, Y and Z. I've got the steps per millimeter exactly the same. That should, in theory, mean that they will move the same. I'm not going to reset the dial gauge now, I'll probably do it at the end, but when I move X and Y and 8 millimeters, they move exactly 8 millimeters. And with backlash enabled, doesn't matter which way I move them, they still move exactly 8 millimeters. So, that tells me that if, let me just get to a calculator, and I know this isn't perfect because anyway, it's not a perfect calculation, but if I say, it's supposed to move 8 millimeters and it's moving 7.95 millimeters. So, if it'll focus, 0.05 times 100 divided by 8 equals. So it is 0.625% too little. So I take that, 628.8, which I measured doing similar calculations. So I go 628.8 times 0.625%. You can see I need to add 3.9 steps per millimeter. Roughly, it won't be perfect, but it'll get me a bit closer. So let me add 3.9 to that, so it'll be what was that before? Add 3 millimeters to that, 4 millimeters to that will be 632.8, so 632.6. 632.6. Make sure it's for Z. Save. Okay. And now rerun tests. Again, this is to get make sure the steps per millimeters are correct without backlash. So I'm not adjusting the steps per millimeters to include the backlash, which will fuck up my actual movements. Okay. And now I'm going up until it gets to 0, and I say that's Z0, and I want to go to 8 millimeters. And you can see that's a lot closer. Ain't that cool? Okay, so if I want to go down now, just to check, so I 0, Y, and I want to go down another 8 millimeters. Yeah, that's still not great, but it's better than what it was. Let me just make sure, do a sanity check that I was doing that correctly. Go up 8 millimeters. You can see that's very close. Sorry if this isn't really in focus, I'm trying to record this while actually doing it. So I want to go down 8 millimeters. Let's see if it does that again. Now you can see that's within 0.03 of a millimeter, which that's what? So 0.1 millimeters is 4,000ths of an inch. So 0.04 millimeters is within 1,000th of an inch, which is pretty good. So that's not perfect, but I'm going to accept that because this whole thing, you can see if I move that, the actual head moves. I've tightened up the gibs, but I couldn't do it properly. Anyway, you can see if I move that, it moves about that much, maybe a little bit more. So I'll accept that. So now, what I need to do to adjust the backlash, if I 0, Z, and then go down so I know that there's no backlash in that direction, and then go the other direction, just gently. So there, you can see the backlash is about 0.12 millimeters. So config, backlash, and I go 0.12 millimeters. Okay, and now if I 0, and I want to go to 8, so let's see what happens. Okay, that's good enough, and now if I want to go to 0, and this is, I haven't changed the height or anything to compensate myself for backlash. And sanity check, going up again. You can see that's within 0.02 millimeters, which, you know, I'm going to accept that I don't think there's much else I could really do past that. That is getting in. This isn't, you know, the most precise machine ever. It's meant as a hobbyist machine. You're looking at a hobbyist. That's a hobbyist machine. It's perfect. There's really not much more. I can't really get much better than that. Well, no, I lie. I can. I can replace the couplings, which you can see in there. Those are some couplings that they use. Those are fine. I thought that was the issue, but it's not. I think it's in the ball screws themselves. If I really wanted to get pedantic about it, I can replace the motors, the couplings, and the ball screws, and true up the head. But realistically, I'll probably do it at some point. But the machine is good enough for now. So I recorded a little clip of footage of myself doing almost this exact thing before I decided to check for Backlash. And I'll probably put that little snippet of footage in now. If you'll look right now, if it'll focus, it is at 0. And I'll try and do this. What I'm going to do is I'm going to increase it by 5 millimeters. Come on. Why are you no worky? Oh shit, sorry. Decrease it by 5 millimeters. So this is going to go down 5 millimeters. Each little line on that is 0.01 of a millimeter. How perfect is that? Let me go up again, another 5 millimeters. If that isn't within 0.01 of a millimeter, and I don't know what is, that's fucking perfect. So you can see that was really good. The problem is I still wasn't getting a precise part because I said I wasn't compensating for Backlash. I was compensating for Backlash, but I was compensating for Backlash with the wrong steps per millimeter, so the parts weren't actually coming out right. So hopefully now that should be better. I will change around the dial gauge to show you X. I'm not going to do Y because it's a pain in the ass to maneuver it everywhere, but I'll change the dial gauge to show you X. So I'll be right back. Okay, I'm back. I moved the dial gauge so that it's measuring X. And I'm going to move it over until it just starts touching. Okay. And it's on 0. Remember to 0 X because I'm a fucking idiot and didn't do that and almost crashed the dial. Insert that clip here. This should move perfectly. Anyway, let's not linger on our mistakes for too long. So X is zeroed. I am going to move X 8 millimeters from 0. So you should see it move exactly 8 millimeters. And you can see without Backlash, within 0.001 of a millimeter. No, not 0.001 of a millimeter. 0.01 of a millimeter. And now enable Backlash. And if I now go to X0, it should be directly on 0. Perfect. Now to 8 again. This is with Backlash compensation enabled. Not too great. Let's try that again. That's pretty good. You can see it varies a little bit. This probably isn't the most accurately perfect, precise dial gauge ever, but it's pretty good. So yeah, that's the machine trammed in. I'm going to load in a block of wood and try to cut a 22mm circle for a bearing for a fidget spinner. So I will stop the video now and I will come back when I'm running the G-code. Well, would you look at that? A perfectly and strategically placed block of wood, 6mm end mill, and G-code path. Now all that's left to do is to press cycle start and hope nothing bad happens. Yes. Hand on ready, spindle should start. And you'll notice, I don't know if you can hear me or not, but you'll notice there's like a tick every time it changes direction. That's compensating for the backlash. And there it's cutting. Just adding some air. Don't want to load up too many chips. And you can see there it's cutting the perimeter. I need one of those like things that are attached to here for air. Because if I'm running something that's longer than like half an hour, this does get annoying. G-code, it's almost done. Okay, cycle stop. No one cares about you. Okay, not you. Compressor. Everyone cares about you. Let's take that out. Shut off the spindle. So now I can't remember if I added or if I left some stock to leave in Fusion 360, because that is what I used to do that. If only I knew where the digital calipers are. There they are. Why they're underneath the tap set, no one knows. So let's see. If it says something like what does that say? 21.6. 21.6, it's meant to be 22. So if it's a 0.2mm stock to leave, that's perfect. If not, then I don't know. Let me just do that again. Yeah, 21.6mm. If it's a 0.2mm stock to leave, which it could be, then that's perfect. If not, then I don't know. This I'm probably only going to use this for like visual stuff and not precisely accurately machine stuff. But let me go check Fusion 360 and see. So I'll see you at my computer, I guess. Okay, so I'm here in Fusion 360, and here is the model. This is the toolpath.
So if I edit it, you can see I set 0.1 millimeter stock to leave, which would mean the 21 points. I got 21.6 millimeters. So then once it's done the 2D contour or the final path, or sorry, after this, it should have been 21.8 millimeters. So 0.1 of a millimeter on either side of a circle brings 0.2 millimeters. So that means I didn't go down all the way, because if you look at the tool path, wrong way around. If you look at the tool path when it goes, and if you have paid close attention to the video, just speed that up a bit, quite a lot. See, it does two passes. So I don't know if when it's doing the last pass is when it's taking it to its final diameter. Although it should just take it to the final diameter in one pass. When every pass that it does, it could, I'm not sure, I don't feel like going to run it now. So in an update video, I will tell you whether letting it go through the full cycle will bring it to its final depth, because it's possible that even though it's a roughing pass, it'll do one roughing pass, it'll do multiple roughing passes in the same pass. So when it does the first, it won't take it to its final dimension, in other words. Which is possible. I'm not saying that's not possible because of tool deflection, all that special stuff in Fusion 360, but that's possible. That's a possibility. But I will tell you that when I did this before, I don't think I was getting 21.6. I was getting something else, but I don't know what it was. But anyway, for now, I'm gonna call that good. I can always compensate for that in my CAD if I want to, like for something like this. This is, if you're curious, this is meant to be a it's meant to be a fidget spinner bottle cap opener. So you can't see me now. I'm trying to demonstrate with my hands. That's supposed to be a bottle cap remover. And there's supposed to be a bearing in there, so it's multi-purpose. But anyway, that's kind of good for now, I think. My room is dark right now, so I'm not going to turn the camera on. But yeah, that's pretty good for now. You should see a video about this soon, once I figure out the clamping in aluminium that I want to do, because I want to do this in aluminium, so it's metal and not just a plastic, which would break trying to remove bottles. So yeah, that's it for this video. You can't see me right now, unfortunately, but no, I am waving at you. So goodbye.
So on an alternate note, the phone that I was using to record the video that you've just watched, I accidentally recorded in 4K. Now I'm copying it over. A fucking hour and 5... Oh, okay, now it's half an hour. Still, it's an hour and 15 minutes. Fuck. It would take me so long to upload 4K video. Fuck that.